Our next lesson is called increasing and decreasing functions. So we're going to take a look at example 1. It says examine the graph to the right. So we're going to take a look at this graph at the right, and at this time I would like you to make sure that you have either 2 highlighters of different colors or 2 colored pencils of different colors. We're going to be highlighting or coloring on the picture to help us determine the places where the graph is either increasing or decreasing. So we'll start with part A. It says highlight where the function is increasing. So we're going to highlight in yellow here the place where the function is increasing or going up. So before I do that, I kind of want you to take a look at the graph and see that this is split into 2 pieces. The piece on the right is the piece that is increasing. As x goes up, y goes up. So I'm going to highlight the right side of the graph as my increasing section. Next, it wants us to state the interval of the domain below. So whenever we are trying to identify the portion of a graph that's either increasing or decreasing, we always use the domain to describe that area. And we are going to write that in interval notation. So looking at the picture, if I was going to describe it verbally, I would say when x is greater than 1. Now, we are not going to include the number 1 because any of those turning points or spots do not count as part of the graph that's increasing or decreasing. So these are going to be open intervals. The number where it's changing is never going to count. So if it's when x is greater than 1, we know that 1 is the lower bound. It can continue to increase from there forever, so the other side is infinity. Infinity is always open, and the 1 is not included either, so we put a parenthesis to show that. So that's the interval of the graph that is increasing. Now when we go to part B, I'm going to switch to a different color. So it says using a different color, we're going to highlight where the function is decreasing. So this is where the function is going down. Now looking at the graph, even though the arrows point up to show that this graph continues to go up and out, when you look at this portion of the graph, as the x values increase, your y values are coming down. So that's a decreasing section of this graph. So again, we will state the interval of the domain of that decreasing section. So this is when x is less than 1. That means that this time 1 is my upper number, my highest number. So the comma, the 1 is going to come after it with open parentheses. And on the left, we're going to go towards negative infinity, not included. It says highlight where the function is increasing. So again, we'll highlight in one color. And we'll state the interval of the domain below. So remember, you're thinking about going uphill, increasing. So I see a few spots where this is actually happening. Even though, well, let's add arrows first. There should be an arrow on this end and an arrow on this end. Now, the first one can be a little bit confusing. I know that the arrow on the left-hand side of the graph is going down, but if we were coming along here from left to right and traveling, as soon as we hit this line, we would have to go uphill. So this actually is an interval of increasing up until the value x equals -1. The next place where I would come along from left to right and have to go uphill would be starting at 1 and headed up. So we should have 2 sections that are highlighted in yellow. We will state the interval of the domain below. So first, let's describe it. We can see it's when x is less than -1, because that -1 cut off here and below. Then we can see that +1 cut off and up. So we'll say or, because you can't be in 2 places at once, that's an or, x is greater than 1. So to show that in interval notation, we'll start with the section that's less than -1. We are coming from the negative infinity side, working our way up to a high point of -1. Neither are included. Remember, for or, you need to use the union symbol. And then we have a lower bound of 1 up to positive infinity, neither included. So now switching to a different color, we're going to highlight the section that is decreasing. You are going downhill. That would be this section right here in the middle. If I were to describe that in words, I would say when x is greater than -1 and less than 1. So this time, and. Because you're going to be sandwiched in between those two numbers. So for this interval notation, our lower bound is -1. Our higher bound is 1. Neither of them are included, so you should have open in parentheses. Remember, we never include those turning points. Okay, next, we are going to look at a new graph again. We're going to highlight where the function is increasing and state the interval of the domain below. So increasing, remember, you're going uphill. So if I look at where I would be going uphill, it should be this section right here up until -2. So you can see that's our cutoff. So to describe in words, we would say when x is less than -2. And if I were going to write that in interval notation, -2 is my upper bound. So negative infinity would be my lower bound with parentheses around both. In part F, using a different color, we'll highlight where the function is decreasing. So remember, negative slope going downhill, which is this section of the graph. Now, I do want to add a couple things. There should be an arrow coming off of the yellow section. That's why we were going towards negative infinity. But this time, you see that there's a dot right here at the end of that section. So that is going to change things a little bit for us when we go to list this part. Here, our cutoff is, we're looking at 3 and on. So we'll write when x is greater than 3, and, that's important, less than 8. Now, it really should be less than or equal to 8 because there is a solid dot, but we talked about the fact that intervals, we don't include the number either way. So here you want to have 3, 8. Okay, in part G it says, was there any part of the graph that was not highlighted? Why or why not? So we definitely have a section that we never highlighted. It's that middle section right here. And that line happens to be a horizontal line. So if we go to describe this, we're going to say the horizontal line segment is not highlighted. All right, this is because if you look at that picture, it's not increasing nor decreasing. So what that is showing is that as the values go on, there is a part that remains constant. So we'll say this is because there is no increase or decrease. And then we'll end with it remains constant. And we're going to underline that word because it's so important vocabulary-wise, describing the situation in that section. Now, as a tip to help you out, it says, let the ant help you determine increasing and decreasing intervals of your function with no highlighter. So when you're looking in the future to complete these types of questions, it is helpful to use the tips that you see below. Think of a little ant and whether they would have to go uphill or downhill. Okay, so describe the ant's behavior in the left picture. If you notice in all of these, whether the curve is swooped down and concave or convex going up like a hill, in either of those situations, this is where you're going uphill or increasing. In the other picture, you can see he's going down the slide. He's coming down that other side of the hill. This would be downhill or decreasing. Now at this time, what I would like you to do is try the practice questions. There are 2 practice questions, one here and one on the next page. I'd like you to try your best to answer these questions on your own. So at this time, you're going to pause the video, try the problems, and then resume the video when you're ready to go over your answers. So at this time, you've had an opportunity to try the practice questions. Let's go over the answers. In number 1, it was an open-ended question that just had certain restrictions on where the function should be increasing or decreasing. So it says, draw a function that satisfies the following. Now, first of all, answers will vary. There are many answers that would work for this. This is just an example. And I chose to make all linear sections, which means all the pieces are straight lines. However, if you wanted to, you could create sections that were curved. So my first increasing section is coming from negative infinity up to -3. So I'm referring to this portion right here. So I plotted a point where I knew my x value was a -3. It doesn't matter what my y value is. And you can see in this portion of the graph here, I made sure it was pointed down to the left, which means if I was coming in from the left-hand side, Ski-Bird would go uphill, which means that's an increasing section, and it's going to continue towards negative infinity. The other increasing section was 1/4, so we'll come back to that. From -3 to 1, I'm supposed to be decreasing. So from an x value of -3 to an x value of +1, I have to make sure that I go down, which I did in that center section. Then we pick it back up again at 1/4. So from a value, x value of 1 up to an x value of 4, I have to make sure it's increasing. And then this one's really important as it is interesting and unique to the rest of the sections. This is where I need to stay constant. Constant means I'm staying the same. So I need to make sure that from a value of 4 all the way up to infinity, I am staying at the same exact level. So since I am already up at a y value of 7, you can see as my x's continue to go on to the right, I'm staying at that same y value of 7. So that's showing constant. There should be an arrow on the end showing that it's going to continue doing that all the way towards infinity. When we look at question 2, it says use the chart below to list the similarities and differences between the 2 graphs in terms of increasing, decreasing, and rate of change. So first, we have to find the rate labeled between points. You can use the slope formula to do that, but also since we are working with graphs, you can use rise over run. So you can see I diagrammed my slope or my rate of change on each of these. On the left, you can see my rate of change is not staying constant. I went down 5 to the right 1, but then I only went down 3 to the right 1. So already right away, I know I don't have the same rate of change over and over again, which is why my graph is giving me this nonlinear shape. When I look at the graph on the right, every single time I went down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, which means I have a slope of -2 that stays constant throughout that entire graph, which is why I have a straight line there. So when I go to compare the two, as you can see, there's my answers for the rate of change. For the curved graph, it is not a constant rate of change. For the straight line, it is a constant rate of change. And now for what we learned today, increasing and decreasing. For the curved graph, you see that the left portion, or when x is less than 1, which is the technical turning point that you see up here, we are decreasing. As the x values go up, the y values are coming down. So there's your answer there. And then from 1 and up, we are increasing. So that's from when x is greater than 1 or 1 to infinity. If I try to do the same thing for the other section, there's only one type of function that's happening. It's one piece and it's decreasing the entire time. So I wrote always decreasing. So now for the lesson summary. Here's a picture of a graph just to give you more examples. And as you can see, I've highlighted there, read from left to right. You always want to make sure you're coming from the left side of the graph and reading it like you would read a book from left to right. And that concludes your lesson on increasing and decreasing functions.